Hey class, so this is worksheet 3.4. This is the one about isotopes. So what are isotopes? Isotopes are those atoms from the same element that have different number of neutrons. Just like if you take a look up here, you will see lithium 6 and lithium 7. Those two are isotopes. That means that they have the same number of protons but different number of neutrons. And because of that, they have different mass numbers, which is what these are right here. So the 6 and the 7 is the mass number. The mass number is, the first thing I'm going to do is cross off atomic mass here and put mass number, that's the little number sign, so that you guys know that mass number is in reference to, let me just see if I can unlock this and move this whole thing down a little bit. I'm doing that so that I can make some notes up top. Okay, so again, I'm going to get rid of atomic mass, put mass number there so that you guys know that's the number of protons plus the number of neutrons is what makes that number, which is also the same as that number there. Isotope symbol looks like this. That would be Li, has 3 protons, and in this case has a 6 for a mass number. So the mass number goes on top, the atomic number goes on the bottom, which you can find on any periodic table. I didn't just make that 3 up. So we can go with 6 here, so whatever number is here goes here. And then atomic numbers on the periodic table. For lithium, it's 3. Number of neutrons is very simple. We're going to take the mass number minus protons. There we go. And whatever that equals then is going to be the number of neutrons. In this case, the number of neutrons is 3 because 6 minus 3 equals 3 neutrons. Number of protons is always, I'm going to highlight some stuff here, is always the number, whoa, what happened to my, I'm going to put that down, pick that back up again, and there it is, highlighter. So, number of protons, atomic number, always the same. And that's the same as that there. The number of electrons in this case is going to be the same because we're not dealing with an ion. And the nuclear charge is going to be the same but with a plus charge. Okay, so as I go through this, lots of things are going to be the same. The atomic number, protons, electrons, and nuclear charge are all the same. On the isotope symbol, the 3 at the bottom is always going to be the same too as those things that I've highlighted. So let's take a look at lithium 7 so you can get an idea. First I'm going to do a 7 there, a 3 there, it's still lithium. So there's my isotope symbol. I keep calling it a nuclear symbol because that's what I'm used to, but this says isotope symbol. The mass number now is 7 because that's what that number means. The atomic number for any lithium atom is always 3, which means 3, 3, and plus 3. I can do that automatically. The number of neutrons is 7 minus 3, which of course equals 4. And that's how you do that. We'll do one more just for good measure so that you guys get an idea. We'll switch to a different element. We'll do boron. Boron has a mass number of 10, like that. So boron is B. 5 protons. In this case, there are a mass number of 10. And then the atomic number is the same as on any periodic table. You can check B. B has 5 protons, so I can go 5, 5, and plus 5, just like that. Then it just comes down to the number of neutrons. 10 minus 5 is 5, in case you need to see that. 10 minus 5 equals 5. Okay, good. I'm going to just skip ahead and just take a look at some of the other stuff that's on here. Here are my nuclear symbols. An isotope of 18F, that's a isotope, it's a mass number of 18 right there. And of course it's fluorine. So the only other answer that you can have that's an isotope of fluorine would be same number of protons, different number of neutrons, which means different mass number. An isotope will always have the same number. Okay, we've talked about this. Okay, I am hoping that you can go through the rest of these. Here's the one thing I will go through though. What is your quarter grade for categories that have the following weights? 60% of your total score is tests. 30% is lab scores, and 10% is quiz scores. So what we do, this is called a weighted average. Weighted average is how we actually find the atomic mass, because it's a weighted average of all the isotopes. So this actually will represent exactly the same kind of thing that we would do. Let me make sure I have my calculator here. Okay, so 60%. So what I'm going to do is take my score of 70 and multiply it by 0.60, since that's what 60% is changed to decimal. 60% changed to decimal. I just move the decimal point 2 places to the left and I get 0.60, like that. Okay, I do the same thing for the lab scores, 0.30, and I do the same thing for the quiz scores, 0.1, like that. When I multiply these two like this, all I'm going to do then is add them all up. So let's get to my calculator. 70 times 0.6 is 42. 90 times 0.3 is 27. And 95 times 0.1 is 9.5. And then I add them all up. And what I get then is a 78.5%. Okay? And that's how you do a weighted average. You take your score times whatever the percentage of that is, score times percentage, and then you simply add them up. Okay. All right. Good luck. Hope that helps.